Okay, so calculating the buoyant force on a piece of metal which sinks and a piece of wood which does not sink. So I had already gone through the pre-lab, which hopefully you listened to. And so we know that the buoyant force on any object is equal to the density of the object times the volume of the displaced fluid, so how much of the object is submerged, times g. And so that's what you were measuring for the lab. You were also calculating the differences of the weights. So first thing we need to do is start with a free body diagram. So I know that I have the weight of the earth, weight on the object due to the earth, and then I've got buoyant force going upwards. And I also have the force of the scale. And the force, okay. So for the metal, this was pretty straightforward. I can easily calculate, all right, so the weight, I find this on the bench scale, and the force of the scale, I just literally measure, and this is equal to the weight in water. And so I know that the buoyant force is just going to be the difference of weight minus force on the scale. Now, what's weird about the wood, I don't know if you realize this, because it floats, the force on the scale is equal to 0. And so the wood doesn't actually have a weight in the water. So hopefully that helps you kind of figure out what you were supposed to be measuring. And then, of course, the volume displaced is just equal to the volume of liquid running into the cylinder. Now, I will definitely do much more of a wrap-up next week, but I wanted to kind of catch you close to what you were doing. So number one, you should know that the buoyant force is the weight of the water displaced, which is equivalent to the difference of the weight of the object in air and water. Number two, the apparent weight of the wood in water is 0 because the buoyant force is equal and opposite to the weight of the wood. And that will always be true when an object is floating. Number three, would an object weigh more or less if there were no atmosphere on Earth? And the answer is it would weigh more because the air does give us a buoyant force, which I tried to hint that to you in the intro video. So the air buoys us up, and so we weigh less than we would in an atmosphere, or in a place with no atmosphere. Number four, block of metal, block of wood of identical mass were submerged. Would the buoyant force on both be the same? Why or why not? The buoyant force on wood would be bigger than the buoyant force on metal because the wood has a lower density. It occupies more space and therefore displaces more water when it is fully submerged. And then the answer to number 5 is 0.068 newtons.